I'm just dedicating a little bit of time just to the height, but it doesn't mean that we're stopping everything else that we're doing. Okay, so page 28, if you have a couple of highlighters, it's probably going to be a good idea because I'm going to slide to help you out to have everything in one place. Right? Okay, so when we talk about finding the height of oblique triangles, okay, uh, just make sure that the height is perpendicular to the ground or the base, right? What does perpendicular mean, guys? It just means that when two lines meet at a 90, that's what we call perpendicular. In other words, if you were to use a measuring tape to measure the highest point, you would make sure the tape creates a 90 degree with the ground, right? A 90 degree angle with the ground. And so the height can be in three different places, guys. Watch this. It might be inside or outside the triangle. So in this case, I would say this height here is inside the triangle, right? So you have your three sides of the triangle. The height is actually not a side, but it is inside, right? So here you have your triangle, but the height is outside the triangle. It's not even inside. It's not a side and it's not even inside, right? And then when you have a right triangle, one of the sides actually happens to be the height at the same time. Okay, so I'll say inside triangle, outside triangle. The side is equal to the height. Okay, that's actually one of the legs is equal to the height. So I don't know if you wanna, right? We have our triangle there. We have our triangle here. This is the triangle at hand. And watch this, you gotta be careful, right? Like that you don't, kind of the yellow and the green, they mix, right? So those are the three things you need to always take into account. Like if something is leaning over, like the Tower of Pisa, for example, it's a classic example, you would measure the height at a 90 degree, right? That's how high it is. The length of the tower is a different story, right? The height is measured from the ground up, okay? So let's look at an example here, how height comes into play with our knowledge that we have for trig, okay? So Kat and Steve are hiking at a provincial park in BC, right? They follow the creek and they're 20 meters apart. So you can kind of envision the story, right? Steve and Kat are here and they're 20 meters apart. I will start having partial diagrams, guys. You need to fill in the information. That's what it's going to start happening a bit more. So 20 meters apart, we got that. And they spot a pika, which is a small mammal, right? Opposite. So the creek is flowing here. And across that creek, there is the pika, right? And so this is the scenario that is depicted there. And so let's answer some questions here. How far is Kat from the pika, right? So Kat is here, pika is there. I will call this, would you agree that this is the side that they're, if you look at this question here, which side are they asking for? It's very clearly stated here. This is the distance they're after. Okay? And so I'm going to call that x. So how would we do that, guys? If you watch this triangle, you know which one throws students off is that dashed line. That dashed line is just, what is it doing there? It's kind of annoying, right? So for a moment, just ignore it. Imagine we just started sine law, cosine law, and that wasn't there, right? So do you see what kind of law would you have to use? It doesn't help, right? But what law would you have to use to get this started? If you forget about that dashed line. Cosine law, sine law. Can you possibly get a pair in the mix? You know, two angles, right? You see these here? Can we find that top angle there? Absolutely. So I will actually do that right here, right over here. I'm going to say this angle right here. All right, I'm going to figure out what that is. I'm just going to go 180 minus 17 minus 36. Okay. And when you do that, you get 127 degrees. Okay. So you have a pair now, and you got to be careful because, guys, listen carefully. This 20 is the whole side here, right? So that whole side is across that whole angle here, 127. Okay, so you have a pair. So sine law is going to get you started here. So let's go ahead and do that. Sine of 127 over side across from it is 20. And which angle am I going to have to use, guys? What's across side x? It's 36. Okay, so you might think, hey, that's Steve right here. No, no, no. You're just using that angle because it's across that side, the one you want. Okay, so we're going to go sine of 36 over, we call it side x. Okay, and then you cross multiply and divide. So this is not new to you at all. It's that dashed line that is, we just have to learn how to deal with it. Sine of 127. And I think I have enough room to just answer that here. So go ahead and calculate that. I always hit equals when I multiply. I multiply that, and then I go divide equals, then divided by sine of 127. So it's 14.72. And we are in meters, right? So this is the distance from cat to that mammal, right? Pika. So you just figured that out. Let's do the same thing here for Steve. I'm going to use the exact same pair that I started with the other side. Except for now, if I want, what are we going to call this side? Let's call it Y. And maybe, just maybe, I will highlight that and tell you that, yes, you want this side, and therefore you got to use the angle across from it, because that's what sine law states, right? You got to pair them up for you to be able to use sine law. Cross, multiply, and divide. We would expect a side that's shorter than, right? 36 is a bigger angle. We got this much, right? So 17 is less than 36, so this should be a shorter distance. I already calculated that. I'll just tell you that that's 7.32 meters. Okay. And I have that under this question, so I don't really need a statement there. Right? I have it where it belongs. So now you have both sides solved. And here's where it gives it a little twist. I give you a little, I foreshadowed this yesterday. Is he using English terms? I'm sure you've heard of that, right? Here's where you got to see the connections, guys. Like if you want the width of the creek, what did we just call that up here? What did I call that? That dashed line. We call it the height of the triangle. But if you lay it down flat, it's also the width of the creek in this case, right? If you go bird's eye view. So it's the same thing. So let's go ahead and do that. I will tell you this. We're going to cut it using the dashed line, and you can either use this triangle or this triangle. In this case, it doesn't matter because you have enough information for both of them. So come with me. I will do them side by side here. So let's make this, I will actually have a dashed line here. This is what we call the width. Just make one of these. I would strongly recommend you do that. And this side, we calculated. We can actually copy that onto there. That's 14.72. What else do we know about that triangle? If you look up, what can we transfer? We can transfer that 17, right? This one? 17, that comes with us. Let's bring it with us. I'm just going to ask because it happens all the time. Can you bring the 20 down? You can't. Because you cut it, right? The 20 belongs to the whole thing, to the whole triangle. So you cannot bring the 20 down, okay? All right. Let's focus now on this triangle right here. Do you have a pair? You do have a pair. You will notice, guys, I would say 70% of the time you use sine law, 30% of the time we use cosine law. That's just how it goes. Most of the time we use sine law, but not always. You just need to know when to use what. But here's our pair. So we're going to go sine of 90 over 14.72 is equal to sine of, we have 17, correct? Which is across W. I want to stop here before I go ahead. Make sure you copy this down, right? Guys, 17, we used 17 for what before? We used 17 to figure out this side, right? 17 is across this side, yes. But now that we sliced it, 17 is now across this side right here. That's still true, right? But you do not have the 20 down here anymore, so you cannot use the 127 either, right? Because the 127 was for the whole triangle, the big triangle. That's why I didn't bring that with me. So I have my pair here, and the 17 is going to allow me to find W. So just go ahead and cross multiply and divide just like before. 14.72 times sine of 17. Anybody remember what sine of 90 is? There we go. You're good listeners. And it also is there in the box. I don't know if you saw that. So when you multiply this, you don't need to divide by sine of 90 because it is 1. You get 4.30 meters. Could you have used Pythagorean theorem with this one? If you had enough information, yeah, but you didn't. You only need one side, right? So you can't. But if it happens, I'm just weary about it because some of you would bring the 20 down here. As soon as you bring the 20 down here, you should notice what? Wait a minute, the hypotenuse is always the longest side, right? How come it's 14 and this is 20? Right? You should see a lot of flags as you do this if you really think about your work. And you might get an error as well on your calculator. What is life without connections, right? I think I don't want to do it right now because I feel like it's going to take up too much time. But you could, if you look at my key here, I'm just going to show you. I use the other side. Cut, right? I have them side by side. And you notice that you get 4.30 no matter how you do it, right? So it should work out like that. So if you had used the other side instead, why is that important to know? Because sometimes you will have worked with one and not the other. Like, let's say this question would have only asked you to solve for y, not x as well. Then it's probably not smart to use this side. You would actually want to use that other side, right? So just be smart about it, and be careful how you cut it, and be careful what you bring with you, right? Okay, I'm gonna pause there and I'm gonna ask you to practice this right away. Right away. So go with me to page 29. Page 29. I want you to do all of 29 before you go today, okay? I will give you the answers as you work. Really, you know everything there is to know on how to solve it. I just introduced some new maybe concepts there. So you're going to start with a big triangle. Notice that, right, there will be some kind of height later on. So just keep going through the questions and solve what you need to. And just look up for the answers if you're interested. I call this angle A here. If there are no letters, go ahead and do that, right? Wait, why is he doing or? Why am I giving you two answers for the first one? Because you can use both laws. I give you enough information to do either cosine or sine law. So they're slightly off, but that's okay. Whichever one you go with is fine. This is on page 29, and the height of this flagpole should get you 3.53 centimeters. And don't let me stop you. You can keep going after this. Okay, I'm just gonna walk around and make sure you understand.